ni saya akan letak dalam iTel. So kalau untuk saya akan upload dalam YouTube, and then saya akan link the YouTube link dalam iTel. Kalau untuk students dekat Penang, saya akan share the link lah. Saya akan buat list of all the recorded Google Meet class, and then saya akan share dalam WhatsApp group. Saya tak sempat nak buat lagi because it takes a long time to upload 2-hour video. So saya tengah queue up banyak video. Okay, so kalau ada problem with my audio, with my video, kalau dengar tak clear ataupun putus-putus, please let me know. Okay, so the introduction of atomic structure, atomic theory. First, saya nak kamu tahu the history, sejarah, how does the atom is discovered and developed, the theory of an atom. Because we not necessarily boleh nampak these atoms. Atoms are very, very small. They are practically invisible to the naked eye. Kita tak nampak dengan mata kita. If you want to see a piece of atom, we need to use an electron microscope. So dalam this quizzes lesson, kita akan tengok sedikit demi sedikit how is it developed. So I like to tell students the story of the history of the atomic theory, because kalau kamu notice after you heard this story, after you read the story, kamu akan dapati the importance of scientific method, and kamu akan tahu what is scientific method, and kamu akan tahu what is the importance and why do we use it untuk buat kerja-kerja any scientific work lah pada zaman sekarang. Okay, so for example, let's start now. So this is sekejap, saya nak habiskan slide. Okay, so all of this, the atomic structure, how do we develop the atomic structure punya theory, started 400 BC. Okay, started in the year of 400 BC in the ancient Greek. Okay, so pada zaman Greek purba, there's this philosopher, nama dia adalah Democritus. So pada zaman tu, philosophy is thriving, it is practiced widely, okay, in all level of class. Okay, orang kaya practice, orang miskin practice, the middle class practice as in it is discussed, it is a hot topic. Okay, it's a trending topic lah, okay, basically, secara ringkasnya. So there's a lot of philosophers and students. There's a lot of schools of philosophy. The one that you might have heard, maybe Socrates, Plato, and all those folks yang famous. Tapi one of them, the lesser known, adalah macam Democritus ni. So Democritus is a philosopher, ancient Greek philosopher. Dia hidup sama zaman dengan Socrates. No, Plato. Which one is the old one? Okay, so dia macam kurang popular lah. Okay, he's not as mainstream as all the other ones that you have heard before. So one day, Democritus have this one student, I forgot his name. So they discuss maybe everything that we can see right now is made up of smaller particles. Okay, dia punya logic reasoning is, sekejap saya dengar. His logic and reasoning is, if you take a block of wood and you cut that block of wood, and then dia akan jadi half kan, and then you take another half, you cut lagi, and then take the half yang kamu dah potong tu, belah lagi, and then take the half that is smaller, belah lagi. Then you keep cutting the smaller block of wood sampai dia jadi paling kecil lah, tak boleh dah nak belah dah. Okay, so this is what he theorized as an atom. So they suggest that an atom is the smallest indestructible particle. Okay, so this is what he called as atomos. Okay, and at this time in history, experiments have yet to be developed. So when they have an idea, when they have a hypothesis, they don't test it out. Okay, so the thing with scientific method is, kalau pada zaman sekarang, meaning of the, if you take a block of ice, kamu buat hypothesis. You notice after some time, a block of ice, bila dia dibiarkan dalam suhu bilik, dia akan start cair. So kamu buat hypothesis kata air akan jadi ais akan hilang kalau terdedah kepada haba. So that is your hypothesis. So kalau that is your hypothesis, kamu kena test. You have to perform experiment untuk buktikan hypothesis kamu tu betul ataupun salah. So if you want to test your hypothesis yang mengatakan kalau ais terdedah kepada haba dia akan cair, you take the block of ice, you develop experiment, kamu sediakan, kamu fikir macam mana nak test that hypothesis. So kalau the simplest one I could think of adalah kamu ambil that block of ice, letak dalam bekas, and then panaskan, letak atas api. Tengok sama ada ais tu cair dengan cepat ataupun tidak. And then you write your findings, and then do a lot more tests to make sure the result is uniform. Kamu buat test tu 10 kali, every time kamu panaskan bekas yang ada ais tu akan cair dengan cepat. So you find out that yes, your hypothesis is correct. When a block of ice is exposed to high heat, dia akan cair. Okay, so that is scientific method. Once you have hypothesis, you have to test it out. And pada zaman 400 BC ni, at the year 400 BC, they have yet to develop scientific method, and they don't test their ideas, their hypothesis. So this idea of atoms died out with Democritus. Okay, dia tidak diperkembangkan. And then we fast forward to 18. Oh my bad, ada practice questions. So bagi sesiapa yang boleh join, please answer this question. Democritus thought matter was made of indestructible particles called what? So that adalah open-ended question. You have to write it out. Okay, so let's see what have the 10 of you answered. Sorry, Sam. So Democritus thought matter was made of indestructible particle called atomos. Okay, that's the Greek word for atom, small particle. All right, so next one. So that was 400 BC. That's how the seed of the idea of atoms is developed. So we fast forward to the 1808, tahun 1808. Okay, here we are introduced to John Dalton. Yes. He is the person who expand on the idea of Democritus. Okay, so he is a British chemist, physicist. He was doing some research, and then he came across ada baca satu cerita about Democritus ni lah, and he thought it was interesting. So he thought a lot about it, and he developed some theories, some hypotheses. They call this as postulates. In the scientific community, they call this as postulate because they developed this theory based on the current finding of the scientific community masa tu. Okay, so dia match dia punya teori dengan dengan the knowledge, the information that they have pada tahun 1808. So they compare dia punya idea dengan journals, scientific journals of other scientists pada tahun 1808 tu. So they called it postulate. Dia tak buat eksperimen, okay, because dia maybe tidak ada budget, tak ada grant, tak ada sponsor, so he doesn't have the money to perform tests. But since he compare his ideas with other scientists, he published these ideas and dipanggil sebagai postulates. So John Dalton developed the spherical atomic model. So he is the first person yang mengatakan atom tu berbentuk sfera. So he proposed that atoms are small, indivisible particle. Okay, bahan yang kecil tidak boleh dipecahkan, tidak boleh dibelah. It cannot be divided, it cannot be created, destroyed. Okay, an element, the atom of the same element adalah identical. Atom yang mana daripada elemen yang sama, dia mempunyai rupa yang sama, property, sifat yang sama. Okay, different elements have the atoms of different elements have different properties. Atoms of different elements combine to form compound. So some of his postulates kita dapati sekarang, some are right and some are wrong. Okay, so for example, point number 2, it cannot be divided, created or destroyed. That we found to be true. Okay, atom tidak boleh atom kita find out today dia boleh dibelah, tetapi dia tidak boleh dicipta dan tidak boleh dihancurkan. Dia cuma dikitar semula. Okay, dia dikitar semula menjadi atom yang lain, menjadi molekul yang lain. Okay, and also kita dapati betul, an element, the atoms of the same element mempunyai ciri-ciri yang sama. Contohnya, the atoms of hydrogen all look the same, all behave, all have the same property. Okay, and the atoms of different elements differ. So the atoms of element hydrogen berbeza dengan the atoms of element helium, berbeza dengan lithium, beryllium, carbon, oxygen, and so on. Okay, that we found out to be true. Point number 4, different elements have different properties. Yes, also true. Okay, and atoms of different elements combine to form compounds. This is we found to be true also. For example, macam hydrogen and oxygen, when they form a bond, dia akan hasilkan air H2O. Carbon dioxide, carbon and oxygen, when they form a bond, dia akan menghasilkan carbon dioxide. Okay, tetapi yang tak betulnya adalah atoms are small and indivisible, cannot be divided. Okay, today we found out that an atom can be divided, and inside an atom there are subatomic particles, and these subatomic particles also kita boleh divide. Kita tengok what's inside these subatomic particles. Okay, so another more practice questions based on the last slide. Which of the following is correct about Dalton's theory? Which one do you think? The empat pilihan. The first one is he created a spherical model of the atom. Number 2, he said atoms can be broken down further. Number 3, atoms can combine to form compounds. And lastly, he says atoms of the same element are identical, but atoms of different elements are different. So mana satu yang adalah daripada teori Dalton? So ini multiple answer question, kamu pilih-pilih mana yang kamu rasa. Okay, ada 2 jawapan betul kat sini. So option 1 and option 3. So dia cakap he developed the spherical model of the atom, and dia kata atoms can combine to form compounds. Tapi yang 4 ni pun betul, atoms and different elements are Okay, maybe this person salah set. Soalan saya pun tak check. So yang last option also supposed to be right. Okay, the atoms of the same element, similar properties. Atoms of different elements, dia bahasakan dia punya ni pun macam tak betul. Okay, so basically apa yang Dalton kata dalam teori dia, the atoms of the same element have different, atoms of the same elements have similar properties. Atoms of different element, susunan ayat dia saya tengah confuse nak susun ayat macam mana. Atoms of different elements differ in properties. Ini saya tengah struggle macam mana nak explain. Basically option nombor 4 ni saya rasa dia nak kata atoms of, saya bagi contoh atoms of elemen helium punya atom berbeza ciri-cirinya dengan atoms of elemen oksigen. Okay, dia nak kata atom daripada elemen yang sama mempunyai ciri-ciri yang sama but different with other atoms. Okay, so think of macam hydrogen punya atoms all the way down semua sama. Okay, kita ada macam dalam satu bekas you have hydrogen gas. All the atoms of the hydrogen gas mempunyai ciri-ciri yang sama. Dalam bekas yang lain ada gas oksigen. And all the atoms of the oxygen gas all are the same. But kalau kita bandingkan hydrogen dan oksigen, they both differ. Okay. Okay, so that was John Dalton. He was his contribution was his theory, his postulate on the smallest part of the matter cannot be divided indestructible, and then he expanded his theory together some similar properties and so on. And then kita fast forward 90 years ke depan, we are introduced to J.J. Thomson. So this guy, he is a person yang discovered electrons. Okay, so J.J. Thomson performed an experiment. He was di tengah duduk study. He was studying what is electricity. Pada zaman ni, pada tahun ni, during this period in the late 1800s, he was a physicist chemist living in London. So pada zaman tu, pada tahun tu, lampu elektrik baru diperkenalkan, digunakan di jalan-jalan sekitar London. So he was enamored, dia macam terpukau with electricity. So what is electricity? He wants to find out. And also pada zaman tu, scientists gets a lot of funding. Dia dapat grant untuk perform scientific experiments, untuk expand, untuk menaikkan the industrial sector of London pada zaman tu. Okay, so he was performing this experiment untuk mengetahui, untuk study electricity. Tetapi he found something else, which is electron. Okay, so this is the look of the experiment dalam gambar rajah ni. It is known as the cathode ray tube experiment. So basically, dia ada satu tube glass kat sini. So tube glass ni dalamnya adalah vacuum, meaning tidak ada udara. And at one end ada satu electrode bercharge negative. And the other end ada satu electrode bercharge negative. And both electrodes are connected to a power supply. Okay, cathode ray. So bila dia turn on this circuit, akan kita akan nampak satu aliran lah, aliran cahaya. Okay, electricity. So he performed all kinds of tests to this ray of light ni, cathode ray ni. So at one point, dia test the cathode ray with magnet. Dia ambil satu keping magnet, dia letakkan magnet tu di atas glass tube ni. And dia dapati ray tu, cahaya tu akan bend down, turun ke bawah. And then dia ambil the same magnet, dia letak dekat bawah, cathode ray tu akan bengkok ke atas. So he find this interesting because the light bend band menjauhi daripada magnet tadi tu. So kita tahu magnet ada dua kutub, kutub utara dan kutub selatan. And when different kutub placed next to each other, dia akan tarik. When the same kutub placed next to each other, dia akan menolak. Okay, opposites attract. So bila dia turn the magnet around and dia letak atas tube ni, and cahaya tu akan go towards the magnet. Okay, tadi dia go away and now dia go towards bila dia ubah the kutub of the magnet. Okay, so this is basically the test out. Dia mengatakan ada satu bahan, excuse me, ada satu zarah dalam this ray ni yang bersifat sama macam magnet. It has charges. Dia ada charge negatif dan charge positif. Dia ada kutub utara dan kutub selatan macam magnet. So he performed some more experiment yang mengatakan size of the cathode ray ni, okay, the atoms of the cathode ray ni, the bahan-bahan yang ada yang memancarkan cahaya dalam cathode ray ni adalah lebih kecil daripada the smallest atom, iaitu hydrogen. Hydrogen is the smallest atom. So he performed some experiment and didapati the mass of the cathode ray ni adalah lebih kecil daripada atom hydrogen. So that means atoms, inside an atom ada satu bahan yang lebih kecil lagi daripada atom. So ini dia mengatakan the Dalton punya teori adalah salah. Dalton teori kata atom tidak boleh dibelah. Tapi bila J.J. Thomson buat this test, buat this experiment, dia dapati there is something smaller than an atom. So that means inside an atom there are other things and there are the charge, and that charge is negative. So that's why bila kita letak certain side of the magnet, dia akan bengkok menjauhi magnet tu. Bila kita pusing the magnet, dia akan mendekati magnet tu. Okay, so dalam ITA saya ada attach the video of this experiment. Kat sini ada. Oh, tak ada lagi. So kat sini dalam point ditulis Thomson sent electricity through the cathode ray and the gas glowed and the glowing beam of gas could be deflected by magnets. Deflected tu meaning macam saya cakap tadi, dia akan bengkok away from the magnet ataupun bengkok mendekati magnet. So Thomson realized that these cathode rays consisted of negatively charged particles and that all forms of matter contain them. So dia buat conclusion mengatakan semua bahan, all matter that we can see, everything on earth contain this negatively charged particle. So he has discovered electrons. So what is the conclusion that Thomson made? From his experiment tadi itu, apakah yang kesimpulan yang J.J. Thomson buat? Ada tiga pilihan kat sini. Cathode ray tubes are cool, matter must contain negatively charged particles, and matter must contain positively charged particles. So which one yang dia buat? Okay, so I'm ending. So, jawapannya adalah matter must contain negatively charged particle. Okay, dia dapati zarah-zarah yang dalam cathode itu bercharge negatif, and that's we know to this day electron bercharge negatif. So electron satu subatomic particle. Okay, so this is the plum pudding model. J.J. developed this plum pudding model. Again, atoms can be divided, and an atom looks like a plum pudding. A plum pudding is a dish dessert. Dia macam kuih plum lah. Kamu imagine sebiji kuih macam kuih buah, kek buah. If you take a kek buah, kamu potong, kamu angkat slice of kek buah, makan dapati ada macam prunes ke, pudding ke dekat tengah-tengah dalam itu kan. So basically that is plum pudding. So they develop the structure of an atom based on so bila kita belah atom, kita dapati bits of electrons terlekat dalam atom. So dia kata, Thomson kata atom tu di dalam is solid and electrons akan spread randomly dalam atom and dia bercharge negatif. And that the whole solid of atom bercharge positif. So kenapa ada charge positif? Sedangkan dia test dia jumpa yang charge negatif. So this because the is bila satu structure dia hanya ada satu yang bercharge negatif sahaja, dia tidak akan stabil. Kenapa? You imagine this is the atom kan? So imagine there's no charge positive. Okay? Imagine only ada negative charge sahaja. So this negative charge dia ada charge, and you imagine a magnet. Okay, magnet kalau dia charge yang sama letak next to each other, dia akan repel each other, dia akan menolak satu sama lain. So you imagine all this negative charge sitting next to each other, dia akan ada daya tolakkan, dia akan repel each other. So kalau if this is solid, okay, kalau warna merah ni adalah solid, and this blue negative charge ni akan repel each other, dia akan merobohkan, dia akan merosakkan structure solid tu because of the daya tolakan yang dihasilkan antara satu sama lain. So dia tidak stabil, dia akan rosakkan diri dia sendiri. Sedangkan that is not the case. In reality, around us, everything holds its shape. This mouse here, it holds its shape because at the atomic level, it stabilizes itself because there ada something yang bercharge negatif, ada something yang bercharge positif. Kamu yourself as humans, we don't just crumble into dust because we have a negatively charged particle and a positively charged particle. And that is important because dia akan menstabilkan structure kita lah. Okay, so that's why dia katakan the whole block of atom adalah positive and ada bits and small pieces of negatively charged dekat dalam. Alright, so that's why tulis kat sini, he found that an atom consists of positively charged particle and a negatively charged particle, and an atom is electrically neutral. Okay, sesuatu atom tu dia tidak ada charge, dia neutral because the amount of positive charged particles sama dengan the amount of negatively charged. Okay, so that was J.J. Thomson punya finding. This is easy kan? So ada 3 pilihan kat sini. What food did Thomson's model remind him of? So plum pudding is the what? It's a famous English dessert. So that's why everybody knows it. Okay, all semua strata kelas yang kaya, yang middle class, yang miskin pun tahu what is plum pudding. So he figure I better use something that everyone could relate to, so that everyone can understand. So the answer is plum pudding. Tak ada pun saya sebut pineapple ke round grape. Kenapa ada orang boleh jawab? Moving on. Okay, so kita dah go through Democritus, John Dalton and J.J. Thomson. J.J. Thomson was 1907. Sorry, 1890. My God, saya lupa. Berapa tahun dah? Late 1800s, 1897 kan? Saya tak nak. 1904, my bad. Okay, so 1904 he developed plum pudding model. And then kita fast forward 7 years later, we are introduced to Ernest Rutherford. So Ernest Rutherford, he is a Kiwi daripada New Zealand. He is a physicist from New Zealand. He was a fanboy lah, basically the current term. He's a fanboy of J.J. Thomson. So he likes J.J. Thomson punya findings, punya study. So basically he read a lot about J.J. Thomson and dia nak prove that some of his findings are true. So he developed this experiment mengatakan nak membuktikan the plum pudding model adalah betul. Okay, so he developed this experiment, gold foil experiment. So the idea with this experiment is adalah untuk membuktikan the inside of an atom adalah solid and ada bits and pieces of electron, negatively charged particles spread across the atom. So he developed this experiment. Kat sini adalah satu block of power source, dia akan memancarkan cahaya. And then kat tengah-tengah ni adalah a gold foil, lapisan tepingan emas. And then ada macam a metal ring mengelilingi that gold foil. Okay. So when he performed this experiment, dia nak prove the plum pudding model adalah betul, tapi he found it to be wrong. Okay, the plum pudding model is wrong. So why? Bila dia perform this experiment, dia dapati cahaya yang dipancarkan tu akan ditempiaskan, akan dibiaskan, diterbiaskan all over the metal ring. Okay, so kenapa dia ada this metal ring around this gold foil? So that he can see the light goes through the solid, goes through this gold foil. But he found out some of them akan terpelanting ke kiri, ke bawah, okay, pelanting sedikit, corner sengit dekat depan, and corner sikit lagi ke kiri. So these are particles yang dia rasa is deflected by the particles inside the gold foil atoms. Okay. So and also dia dapati this cahaya yang dipancarkan ni adalah positively charged alpha particles. Dia bercharge positif. So expected majority of particles to not be affected and only a few to be slightly deflected. So dia punya jangkaan adalah most of the light akan memancar terus, akan menembusi gold foil terus go straight ahead. Tapi didapati banyak yang dipantulkan, yang ditempiaskan. So this is not consistent with the plum pudding model. So what does this mean adalah, kita akan zoom in. So this is adalah zoom in of the gold foil. So ini adalah the atoms of gold. So what he find out, apa yang dia rasakan, dia punya hipotesis adalah cahaya yang dipancarkan tu, alfa ni adalah cahaya. So cahaya akan menembusi gold foil tu. So bila dia menembusi terus, dia dapati it is because dia tidak berlanggar dengan atom emas. Tetapi ada yang dipantulkan ke belakang, ada yang tempias corner sikit ke kiri, corner sikit ke kanan, and that is because dia berlanggar dengan something yang sangat-sangat tumpat, very dense within the gold foil. Okay, so he concluded that basically because of most of the particles pass right through and 1/8,000 yang deflected, very few particles were deflected straight back. So what he found out was, he discovered inside the atoms are mostly empty space with a very densely particle somewhere inside the atom. Never mind, saya akan explain further later. Kita menjawab dah boring pula. So this is what he come out with. This is his conclusion. He came out with a new model untuk menggantikan plum pudding model. Okay, because he find out from that gold foil experiment, the plum pudding model is not right, it's not correct. Okay, they disprove the plum pudding model because plum pudding model mengatakan inside the atom adalah solid and ada bits and pieces of electron terlekat dalam solid tu. Bila dia buat gold foil experiment ni, dia dapati inside an atom adalah mostly empty spaces, ruang kosong, with something that is massively dense at the center of the atom. Ini adalah nucleus. So ini adalah findings of Ernest Rutherford. Okay, all the people mentioned here won a Nobel Prize. Okay, J.J. Thomson menang Nobel Prize in chemistry. Ernest Rutherford menang Nobel Prize in chemistry because for their discovery. J.J. Thomson won for discovering electron. Ernest Rutherford won Nobel Prize for discovering the nucleus. Okay, so from that experiment, he developed this nuclear planetary model. So some of you may have seen this model. Okay, this model mengatakan at the center of an atom ada satu ada satu bahan yang sangat tumpat yang bercharge positif, and elektron bergerak secara rambang dalam ruang yang kosong and dia bercharge negatif. So the nucleus ni tidak bergerak. It just sits there at the center of the atom, and mostly inside the atom 99% of the inside an atom adalah ruang yang kosong, and elektron bergerak secara rambang. So this is the nuclear ataupun planetary model of Ernest Rutherford. So as you can see, starting from Democritus itu kita dah kembangkan. It takes a very long time, tapi kita dah kembangkan. From Democritus to John Dalton, J.J. Thomson, and now Ernest Rutherford. So on this question, Ernest Rutherford created a planetary model and discovered what region? What did he discover? Apa yang dia jumpa? Kalau J.J. Thomson discover electron, Ernest Rutherford discover apa? So kita jumpa nucleus, jumpa empty space, nucleus atoms, I mean empty space. Okay, so we've seen variations answers. Jawapan yang betul adalah nucleus. Okay, Ernest Rutherford discovered the nucleus. That's the main finding. Empty space is like a minority finding. Okay, and that was 1911, and then years later, Bohr's model. Okay, so he said that electrons orbit the nucleus and have specific size and energy. Okay, because electrons have different levels of energy. So the energy is relating to the size of the electrons. The lowest energy is found in the smallest orbit, and electrons can move between each shell when they gain or lose energy. So Bohr, he performed an experiment also at the electron at a different level of energy, and they can move around the nucleus, and distance tu akan ikut on the level of energy. Sampai dalam diagram ni, saya akan stop cakap dulu. So pay attention to the drawing diagram of Bohr model ni. So this is the Bohr model. So the Bohr model, dia kata at the center of an atom ada nucleus. This is true lah because of the finding of Ernest Rutherford. And what he expects, apa yang dia discover, electron ni ada different energy. Okay, so dia akan orbit, dia akan move around according to its energy level. So kalau elektron yang bertenaga rendah, dia akan move closer to the nucleus. So this is the nucleus. Ini elektron yang bertenaga rendah, dua biji ni dekat dengan nucleus ni. Okay, so kalau elektron ada lebih tenaga sikit, dia akan move to a bigger level, a bigger shell. So farther apart from the nucleus. And kalau ada elektron lagi yang lebih bertenaga tinggi, dia akan move into a higher level, farther from the nucleus. Okay, so this electron akan orbit, dia akan move around the nucleus. Tapi the distance from the nucleus tu depends on the energy level yang electron ni ada. So electron boleh gain and lose energy. Macam manusia, we gain and lose energy. We gain energy from the food that we eat. So the same for electrons, they absorb energy from the most source of energy for electrons adalah cahaya. Okay, so if you remember, light is a form of energy. Cahaya adalah salah satu bentuk tenaga, and electrons gain 99% of the energy from cahaya. Okay. So Niels Bohr studied light. So they take different substance. They can expose this substance to light, and then they can measure the level of energy using different measurements and different kaidah. So he also received a Nobel Prize for his findings. Niels Bohr. So kat sini, Niels Bohr's model electrons blank the nucleus in energy shells, and electrons can move between energy shells when they gain or lose what? Kamu boleh jawab dengan menulis satu jawapan, koma, and then jawapan untuk the second blank. In Bohr's model, electrons, saya pinjam jawapan Iqmal Syafiq. So in Bohr's model, electrons orbit the nucleus in energy shells. Electrons can move between energy shells when they gain or lose energy. Okay, that is correct. Move pun betul lah, saya akan terima. In Vanilla, saya terima kalau ada move, orbit energy, orbit energy. Okay, so correct. Jawapannya adalah orbit dan juga energy. Okay, that's the finding of Niels Bohr. And then kita fast forward pada 1926, Erwin Schrödinger, he developed the quantum mechanical model. So this is the current yang kita gunakan sampai sekarang, the quantum mechanical model. So he discovered that electrons move around the nucleus. Excuse me. Yes, ada orang angkat tangan. We have a question? Kita tertekan. No question, huh? Okay, let's continue. So this is Erwin Schrödinger. He discovered that electrons move around the nucleus in a cloud, not orbit. Okay, dia dapati elektron bergerak mengelilingi nukleus, itu betul. Tapi dia tidak mengorbit macam bulan mengorbit bumi, macam bumi mengorbit matahari. So electrons does not move like that. Dia dapati electrons move around the nucleus secara rambak, secara rawak. Okay, it moves in a cloud. Ada satu kawasan. So electrons move within a cloud and dinamakan sebagai orbital. So orbital helps us predict the area where we can find electrons. Okay, and then didapati the closer the position of the electrons to the nucleus, the higher the chance to find electrons. Okay, because the theory, the logic for his point ni adalah kalau elektron tu mempunyai tenaga yang tinggi, dia akan bergerak dengan sangat laju. So if you imagine you can see electron, okay, you cannot see something that moves very, very fast. So that's why electron in higher orbital, in bigger shells, susah untuk kita tahu dia punya lokasi, dia punya tempatnya within the atom. So that's why they kata the closer the position to the nucleus, the higher the chance to find electron, because the electrons moving closer at the nucleus has lower energy. Okay, so this is what we are working with right now. Atom tidak ada orbit, tapi dia ada cloud. Dia ada macam laluan. And elektron ni bergerak secara rambang within that cloud, within that laluan. Okay, so this model is also known as the electron cloud model. So this is our last slide. In the quantum mechanical model, there is a higher chance of finding electrons when they are what? Sebagian tak boleh join. This is what you can see. When they are far away from the nucleus ataupun when they are close to the nucleus. Okay, most of you got it right. Jawapannya adalah close to the nucleus. Okay, so from that story, that's the end of the quizzes lesson. So from that story, kamu boleh dapati scientific theories can be updated, can be disproved, and can be replaced if we have new findings, new data. Okay, so that's what I like about scientific method. Bila kita dapati, bila kita ada satu idea, kita kena test idea tu. So bila kita test idea tu, eksperimen tu mesti dibuat dalam keadaan terkawal, so that data yang kita dapat tu adalah what's the word? Adalah berdasarkan kita punya hipotesis. Kalau saya macam contohnya saya ada hipotesis, saya nak katakan ais kalau terdedah pada haba dia akan cair. Tapi kalau saya buat test macam saya ambil sebuka ais, saya panas dia dalam bekas, and then apa lagi, saya tambah faktor yang lain, katakanlah okey macam faktor lain yang boleh katakanlah panaskan dia, and then kita kata mesti ada pemboleh ubah, mesti ada two sets of experiment untuk kita buktikan kita punya hipotesis. So that's why bila kita perform any eksperimen, kita tak boleh consider satu condition saja. Kita mesti buat dua condition. Macam kita panggil ini sebagai control and variable. Saya tak kena explain yang baik sekarang, saya tak boleh fikir. And after our break today, saya akan bagi another example untuk explain what I said just now. Okay, so my point here is dalam the history of atomic theory ni kita boleh nampak scientific theory can be updated, can be corrected from time to time once we gain more data. So the people yang discover different models, different parts of the atom, they perform tests. Okay, they perform multiple tests and experiments, and they collect a lot of data. And from that data, kalau dia punya data are consistent to the hypothesis, so dia baru boleh buat kesimpulan. Okay, dia tak perform just one experiment saja. Okay, they perform multiple hundreds of experiments. Sometimes they repeat the same experiments berkali-kali untuk test whether the experiments adalah terkawal, accurate and precise, so that tidak ada sebarang kesilapan dalam membuat ukuran. Okay, so once we gain a lot of data, barulah kita boleh buat kesimpulan. So that is how we progress throughout the century. Okay, so since we have developed, since we have understood the theory of atoms, kita dah banyak sangat advancement in our zaman civilization. Okay, so in the beginning of 1900s, kita dah develop a lot of technologies, a lot of medical equipments, a lot of scientific equipments kita develop once we have understood what is an atom, what is inside an atom, what is electron. Kita boleh study cancer, at the nuclear level. We have obtained GPS. GPS kamu guna sekarang tu waves tu is because we have understood the theory of relativity dan juga the atomic structure. So that everything is connected. We have advanced so much in the past 100 years because we have understood one tiny little thing, what is inside an atom. Okay, so let's take 5. Kita akan continue after 5 minutes. Hi, I'm back. Okay. Apologies for my voice. Down with flu today. Suara pun dah selesai. Okay, saya nak explain about what I said just now, apa yang control, apa yang test itu. So, saya baru teringat one eksperimen masa kita sekolah rendah. Okay, saya belajar di masa sekolah rendah, saya tak pasti ada lagi tak masa silibus dalam silibus sekarang. So, masa saya sekolah rendah dulu dalam subjek sains, we learn about experiment, scientific method. Okay, in fact. So, di ni kita diajar tentang what is hypothesis, how do we test out that hypothesis. So, katakanlah for example, our hypothesis is kita nak kata plants need light to stay alive. Okay, tumbuh-tumbuhan memerlukan cahaya untuk hidup. So untuk test out this hypothesis, kita perlu set up an experiment. Okay, our experiment perlu ada dua set. Satunya adalah control, satunya adalah test. So dalam set control tu, kita letak satu pokok, okay, dalam tanah dan satu bekas. Kita siram dengan air, bagi baja, and then kita bagi cahaya. And then in another set number 2, kita ada satu pokok dalam bekas, tanah dalam tanah, ada kita bagi dia air dan juga baja, tapi no light. Okay, no light. Tidak ada cahaya. So kita punya hipotesis mengatakan ada light. Kita buat satu setup, satu eksperimen kat sini, tumbuhan yang disediakan dengan cahaya, satu lagi tidak. Tapi condition yang lain semua sama. Ditanam dalam tanah, bekas yang sama, tanah yang sama, diberikan the same amount of water, the same amount of fertilizer. So katakanlah we wait out after 7 days. After 7 days we see what happens to the pokok. So of course we can safely assume, because kita tak buat this experiment, we know now plants need light, because after this experiment, pokok yang diberi makanan, baja dan air dan juga cahaya terus hidup. Tapi yang tak dapat cahaya ni mati. So that aligns with our hypothesis. Pokok yang tidak dapat cahaya mati. So barulah kita boleh buat conclusion. Okay, so that is basically how we test out our hypothesis. Kita mesti set up satunya setuju dengan hipotesis kita, satu lagi tidak. Okay. Alright, so moving on, going back to our syllabus, mana kita? Saya nak explain lagi. Okay. So from that history lesson about atomic structure, kita tahu basic secara in a form of story what is inside an atom. So sekarang kita nak bagi nak senaraikanlah dengan lebih spesifik what is inside an atom. So dalam this lesson saya nak kamu tahu each of the subatomic particles. So if you can see in your you can see kan saya dah share screen. So if you can see in your screen right now, dia tulis kat sini dalam this slide, matter is the substance that all physical objects are made up of, and matter is all around us, and all matter is made up of smaller particles, and these smaller particles are known as atom. So what is atom? Atoms are the smallest unit when it comes to matter. Okay, some say that it is the building blocks of matter. Okay, sama macam sebiji bata tu adalah the building blocks of a building. Atom tu adalah the building blocks of matter. Okay, we are manusia, the simplest substance of a person adalah sebiji atom. Everything in our world is made up of atoms. So what are the parts of an atom? At the center of an atom, we know there is a nucleus. Inside the nucleus, there are protons which are positively charged. And also, there are neutrons. So the center of an atom is a nucleus, and inside the nucleus ada dua benda, iaitu proton dan juga neutron. Proton bercharge positif, neutron is neutral. And the electrons move freely around the nucleus. And dia bercharge negative. So these are some of the atomic model yang kita dah tengok tadi. This is the Bohr model and this is the Rutherford model. It basically, essentially, it is the same thing. Dia mengatakan nukleus ada di tengah-tengah, ada proton dengan neutron, proton bercharge positif, neutral, and neutron bercharge neutral, and electron bergerak mengelilingi nukleus. Okay, so these are the things yang saya nak kamu tahu by the end of this chapter. That's the first thing. Okay, what are the subatomic particles? The subatomic particles adalah proton, neutron dan juga elektron. Saya juga nak kamu tahu ciri-ciri partikel ini. Okay, for example, elektron ciri dia adalah bercharge negatif. Proton ciri dia adalah bercharge positif. Neutron tidak ada charge. Okay, and the position of them within the atom. Atom with the same number of proton and electron is electrically neutral. Okay, so for example, kita tahu apa yang dimasukkan dalam point 1 ni, dia kata an atom with the same number of proton and electron is electrically neutral. So that means basically if you look inside the periodic table, katakanlah kita tengok the atom hydrogen. Ya, atom hidrogen dia ada satu proton, one proton, and the other one electron. So atom hidrogen ni dia tidak ada charge. It's not positive or negative. This is because proton bercharge positive and electron bercharge negative. Okay, so if we combine, kalau kita campurkan satu tambah negatif 1 akan bersamaan dengan 1 tolak 1, so charge dia adalah kosong. So dia tidak ada charge. Okay, sama juga dengan helium. Helium dia ada 2 proton dan 2 elektron. So ni bercharge positif, ni bercharge negatif. So kalau 2 negatif 2 sama ada 2 tolak. Tolak 2, jadilah 2 elektron. Saya tengok dalam periodic table. So if I look up in the periodic table, dia akan ada a box like this. Dia akan tulis O is the symbol for oxygen. Dekat bawah ni nama dia oxygen, and ada atomic number dekat atas and atomic weight dekat bawah. So the atomic number here basically says the atomic number is the identification of an atom. Because identity sesuatu atom tu bergantung kepada bilangan proton yang dia ada. So kalau atom oksigen, maksudnya dia ada 8 proton. Kalau kamu tengok hydrogen, dia ada 1. Kalau elemen tu, kalau katakanlah for example, I give you a question. Okay? Sorry. Dia punya mouse jatuh. Right. Excuse me, kenapa ni? Benar. Oh no, what happened? Oh, terus. Sorry, excuse me, jatuh mouse terus. Everything went haywire. Okay, katakanlah for example, I say to you, saya nak kamu find out I give you the property of an element. Katakanlah find in the periodic table, find an element with the atomic number 16. Okay, so find the element yang mempunyai atomic number dia adalah 16. Katakanlah element Y. Okay, dia punya atomic number adalah 16. So how would you do that? Kamu hanya perlu cari periodic table and tengok dalam periodic table mana atomic number adalah 16. So 16 in this case adalah sulfur. Okay, so that's what I mean bila saya kata the atomic number adalah identiti sesuatu elemen, sesuatu atom tersebut, because different atom have different number of proton, different atomic number. Okay, so dia macam IC kamu lah. Okay, your IC is different than your friends, different than your fathers, your mothers, your sisters, and your brothers. It is unique to yourself only. So the atomic number is also true for atoms, also true for elements. The atomic number is the MICAT number untuk elemen-elemen. Okay, so hydrogen, the atomic number is 1. Kalau elemen tu ada 2, atomic number dia adalah 2, dia bukan hydrogen, dia adalah helium. Kalau dia punya atomic number is 3, it's lithium. It could not be anything else. Okay, and also the atomic number is based on the number of proton sesuatu atom tu. So kalau kat sini dalam this slide dia kata atomic number of oxygen is 8, that means oxygen has 8 protons. Okay, so that's why dia kata kat sini an atom is the smallest unit of a chemical element, and an atom has all the properties of that element. Okay, and all atoms have this. All atoms of the same element have the same number of protons, and an element's atomic number tells us how many protons the element has. Okay, so the atomic number tells us how many proton does the element has. So kalau oxygen, the atomic number is 8, that means dia ada 8 proton. If you look at kat sini, beryllium, atomic number is 4, that means it has 4 protons. Boron, atomic number is 5, that means the number of proton it has adalah 5. Okay? 8, not that one. Another 8. Okay, so moving on, saya nak kamu tahu lagi also, the number of electron is also the same as the number of proton kalau atom tu tidak ada charge. So for example, oxygen ni, saya take this oxygen as an example. Oxygen, this is the punya level tadi, 15.9 adalah dia punya atomic weight, 8 is the atomic number. Okay, so this is the atomic number. This is dia punya mass. Okay, so kalau saya nak tahu what is the number of proton does oxygen has, kita tengok dekat atomic number. That means bilangan dia adalah 8. Berapakah bilangan electron does oxygen has? You have to remember the number of electron equals to the number of proton. So kalau proton 8, electron also 8. And also you have to remember kalau saya tanya berapakah bilangan neutron. So bilangan neutron is the mass number ni tolak dengan atomic number. So kalau kita ambil 15.9 tolak dengan 8, you will get the value here. Itu adalah bilangan neutron. Okay, so these are the things yang saya nak kamu mahir by the end of this chapter. Kamu tahu what are the subatomic particles. Kita ada proton, elektron dan juga neutron. Siapa yang positif, siapa yang negatif, siapa yang neutral. And also saya nak kamu tahu how to read this label. Okay, which one is the atomic number? 8 ke 15.9? So you tell by the position lah kalau you. Oh my god, sorry anak saya jatuh. Apologies, sorry. Where did we stop just now? What are the things that your goal for this chapter? Tahu what are the subatomic particles and tahu how to read this label. Okay, 8 tu adalah atomic number, 15.9 tu adalah mass number. So make sure you can tell by the location. Kalau nombor tu dekat atas, dia adalah atomic number. Kalau nombor dekat bawah, then it usually comes dalam bentuk perpuluhan, itu adalah mass number, mass of that element. Okay, so I think that's it for today. Tapi saya nak leave you with a homework. Homework nanti saya akan post di dalam ITEL dan juga WhatsApp group. Okay, ITEL untuk students nilai, WhatsApp group untuk students Penang. Atoms and molecules ni. This is lesson, sorry, my bad. Protons, neutrons and electrons. Okay, dalam this lesson dia akan assess, dia akan ajar macam mana kamu nak count the number of proton, neutrons and electrons. Okay, that will be your homework. So secara tak langsung sepatutnya ada satu saja homework, tapi most of you tak buat lagi untuk tutorial 1. Okay, I can see from here report cohort 42 chapter 1 assessment. A week ago saya dah post. I posted this 7 days ago. Deadline is October 25th. So belum ada orang jawab lagi. So hopefully by this, I posted this 11 October, 7 days ago. So kita akan discuss ni hari Jumaat. So please, at least kalau macam half of you dah buat, kita boleh discuss. Tapi kalau tak ada orang buat ni, saya tak nak discuss. Okay, cohort. Yes, kamu kat luar ke? Bunyi angin kuat.
Yang kuis tu saya dah buat.
Kuis tu kamu dah buat?
Sir, saya pun dah buat.
Yang
saya dah buat juga.
Okey, so ramai dah dapat. Saya tak dapat ini ni. Partisipan pun tak ada. Kamu buat, you got the link dalam ITEL?
Yes, sir.
Ya.
Menarik. Nanti saya tengok balik. Okey, tak apa lah. Nanti saya tengok balik. Cohort Penang. Jadi saya nampak somebody ask about cohort Penang. So how about GC? Oh, GC ni Google Classroom Oh, so kamu prefer Google Classroom? Boleh juga, saya ada banyak Google Classroom. Okay, so nanti saya akan set up satu Google Classroom untuk cohort 18. Saya boleh share semua kat situ, that's better. Okay, saya boleh record everything there. Nanti saya akan tengok balik kenapa this quizzes tak ada sebarang submission. Nanti saya akan update later today ataupun esok. Okay, so itu saja. Unless kamu ada soalan. Okay, kalau tak ada, terima kasih. See you Friday, cohort 18 pun Friday, okay? Oh, cohort 18 saya tak attach attendance lah. Alah. Nanti saya akan pass pada Alvin. Okay, saya akan WhatsApp Alvin the link and then kamu submit later lah. Okay, all. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
all.
Thank you, sir.
Bye-bye. Stay safe.